All right, getting off the ground, the cloud, and 3D printing. So my name is Daniel Lawrence. I'm an application engineer here at DesignPoint. I'm joined here by my colleague Breland Blake, who's also an application engineer here at DesignPoint. Um, and we're going to be doing this presentation on our quadcopter project. And for those of you who don't know or aren't caught up to speed, right, this is a continuation of last year's project, right, last year's quadcopter project that a decent amount of people from the DP team worked on last year. So don't worry if you missed that presentation or you weren't here at last year's MIP. That's okay. What we're going to start off with this presentation is it's going to be a recap of where we got to last year, and that's going to be the start of where we start this year. And then after that, we're going to talk about some of the revisions we made to the quadcopter design and the canopy design. And then Breland's going to go a little bit more in depth into the 3D printing, the actual build of the quadcopter, and then hopefully, show you a couple videos after this of the quadcopter flying. So, like I said, first thing I'm going to do is recap the team that worked on this year and last year. Our project manager was Abby. Right, so Abby, if you don't know Abby, she's an all-star with pretty much everything she does here at DesignPoint. She's great, and she did a great job managing this project. Basically, her role was to make sure everything in the project was running smoothly, that Breland and I had all the proper tasks, and that all of our timelines and deadlines were hit. And clearly, she did a great job because we got a fully flying quadcopter to show you. My role as the design engineer was primarily just working with the CAD models. So all of the SolidWorks models that you're going to see are models that I made, and I collaborated with Breland to get those, get all the proper dimensions and everything that a quadcopter would need through the 3D Experience platform, which we'll show you throughout this presentation as well. And then you see here, Breland's listed as our quadcopter expert, but his role is much more impactful than just being the expert. And I'll let him introduce himself and his role a little bit in his own words.
Yes, thank you, Dan. So I'm also an application engineer here at DesignPoint, and I was the quadcopter expert. So I saw the project, worked with Abby to go over the timeline, and I worked with Dan through the revision schemes. We made all different revisions, came up with the design. Dan ran through the design, and then I had applied any changes that we wanted to make to them, and had Dan make those changes.
Great. Thanks, Breland. And then the next thing I want to show you guys is just get you guys caught up to speed with what Breland and I got to last year with the project. So to do that, let's just start right where we started last year, right? Approaching the design. We were tasked with designing a quadcopter from scratch and then 3D printing it on our MARKFORGED machines. So I love this flowchart, right? This engineering design process chart that you're looking here, especially for when I'm thinking and approaching a 3D printed design, right? If you've taken, or if you guys have taken the 3D printing jumpstart after you bought one of the MARKFORGED printers, you've probably seen this flowchart there, right? I love it. It's really great and useful to utilize for 3D printed designs. So where were we last year? We were here at this center block, right? Identifying those functional requirements and designing that minimum viable product. We assumed, right, the problem, we already knew what the problem was and that we already estimated a business case, right? It makes sense to 3D print this part. But I don't want to gloss over those two blocks, right? Because if you are going to use this workflow in your process and in your production environment, this block specifically, estimating that business case, is really important because not everything should be 3D printed. So when you're thinking about what to 3D print and does it make sense to 3D print this part, or does it make sense to traditionally manufacture it, it's really, really important to estimate and justify that design, right, and that choice before going into it and actually creating it. So But for our presentation, we're just going to assume that we've done that, and we're starting right here on identifying those functional requirements and designing the minimum viable product. So let's show you what we came up with what our first design looked like last year. So where we got to. Well, this is what we got to. If you were at that presentation last year in MIP, this should look familiar with that iconic DP turtle shell there. But what you're looking here on the top left, that was our first pass design of our frame, right? This frame, a decent amount of design intent went into it with the intent to use various different components, right? We're not locked into one specific component, right? All the standard quadcopter parts that are being used, they fall or will be able to connect to this frame. And this was our first design. It's one piece. We actually had another colleague, Julio, last year run a couple of designs, simulations in SolidWorks and in Simulia to validate this design, and it was successfully validated. So we were pretty happy with this first pass design here. And then looking down here at the bottom left, this was our first design and revision of the canopy. Right, the canopy, what its purpose is mainly is to protect or be the first layer of protection of your electronics, right? Because those are pretty expensive. You don't want those getting damaged if this quadcopter were to fall. What the canopy also allows you to do, allows you to kind of make your quadcopter a little bit unique, stand out from anyone else, and that's why we chose to do it with the DP turtle shell here that you're looking here. At the top right, this was our final CAD assembly with all of the components in there, the electronics, the motors and the propellers, the battery and everything that we need to build the part. And then this right here at the bottom right was our first pass, our first print of our designs. And that's where we got to last year, right? So what you're looking at down at the bottom picture here, those were just spare components that those motors and propellers that Brilliant had laying around that we wanted to first check and make sure everything fit and see if we needed to change any of the design at all. And we actually did have a couple of changes right off the bat that we wanted to make, which we'll go into in just a second. But let's go back to our flow chart to see where exactly we are in this design process. So we've just printed our part, and now starting this year, we've realized we want to make a couple of revisions where we've implemented it, and now we're iterating that design and we're coming back and we're redesigning it here. So I'm going to pass it off to Breland. He's going to talk about the first revisions that we're making to the frame, and then he'll pass it back to me. I'll talk about some of the revisions I made for the canopy.
All right, thank you, Dan. So here, what we're showing is some of the revisions that we want to make from last year's frame. Last year's frame was a great frame. I liked the design a lot. The arms were nice and narrow and thin, so they would like strip right through the air and be very sleek and perform very nice. However, with building such a high-performance quad and using high-performance electronics, you're ultimately at some point going to crash. You try not to, but it's inevitable. So we replaced the design with this year. We wanted to cut the arms, and we want to have the arms all the exact same pattern. So all 4 arms are the exact same, and we're going to make this cut here for the arms. And not only were we just going to cut the arms off, we need to have added material for the bottom mainframe and also another plate for the top mainframe. So we're going to actually have a sandwich effect and sandwich these arms from the bottom plate and also to the top plate. We use a 2-hole bolt pattern, so this is going to be a quick repair. If we ever do break in the arms, we need to quickly place, and we'll be back in the air in no time. So what you see here is the revisions that we posted on the platform to communicate those revision schemes to the rest of the team. So what we want to do is we want to detach the arms from the main frame, where I have the illusion there. It's cut. We're going to cut the arms there, and the arms should overlap around the frame, roughly 3/4 of an inch. And then we're going to add these 2 mounting holes. All right, and then there's a reference picture for that. And then our revisions here, as you can see. So our revisions actually, instead of just one frame, that consisted of just 3 parts. So we have a bottom plate, which is the same frame layout of last year's frame, but it's a very smart design. utilizing a 33 by 33 millimeter square pattern for large electronics, or a 20 by 20 millimeter square pattern for smaller electronics. So it's interchangeable between those two. We have the two mounting patterns for the arms on all four corners. It's a symmetrical frame from left to right, and then we just have our slots, which you see from left to right, and that's going to utilize a Velcro strap to strap the battery to the bottom of the frame. Moving over to the center image, the top plate is going to just mimic the exact same outside outline of the bottom plate. The hole cut in the middle is for the electronics. So electronics will sit on the bottom plate, the arms go down all four corners, and then the top plate goes on top of everything. And that hole cutout is to allow the electronics to stick up for adequate cooling and protection. And also the top plate adds extra rigidity to the frame to reduce any kind of flex. And then our arms, we have just one arm, but that arm is going to be a quantity of 4 because they're all interchangeable. So this also makes for a nice added feature too. You get to print a few arms, throw it in a bag, take it out to the fields. If you ever need to replace those, it's just going to be the same arm for all 4 corners.
All right, great. Thank you, Breland, for those revision overviews of what we did for the frame. And then I'm going to walk us through some of the revisions we made to the canopy. So what we're looking at here is the evolution that our canopy took from last year to our final canopy that we have right now. That you're seeing on that little render on the bottom right. So taking a look at this first revision of our canopy, right? It did its job. It worked really well. I think it looked good, and it protected the electronics as we wanted. But once we put this canopy onto the quadcopter, we realized a couple things needed to get changed right off the bat. Right, the first thing was that there's no easy access to the electronics. Right, when you're out flying this, you're out in the field. It's really good and useful to have easy access to the electronics, and the only way that we can get in there and work with those electronics is to completely take off the canopy from the frame and detach it. So not only is that just annoying in itself, based on this first design, it was actually pretty tricky to get that unconnected. So that was our first revision that we wanted to change. The second revision that we wanted to change, or add rather, is that we wanted to take a video of this while it was flying. This way we can show you guys some footage of this quadcopter in flight. So in order to do that, we need to add a GoPro onto the top of the canopy. So that's the second revision we wanted to make. That's where this first revision that of the canopy that I created is that what we're looking at in the center. Let's take a closer look at what this revision entailed and what I added to it, just to see it a little bit more clearly. So when talking with Breland, it's like, hey, I got some extra modeling time, right? We need to add those revisions to the canopy. Let's just come up with a completely new design, right? New year, new design. And when talking with him, we realized that we both thought of alien-like canopy. I think that would look really cool. And the first thing that I thought of when thinking of an alien was of this video game I used to play when I was younger. I'm sure some of you have probably played it. It's called Halo, and one of the vehicles in that game was called the Banshee. So that was my ideology or inspiration rather for this first design. And when looking for a picture to use in this PowerPoint after I created this first design, I creepily found this one, and it was really close to my design, which was not by design. Right, I didn't do that on purpose. It just happened to be really close, and I thought it was a good picture to represent that. But that was our inspiration, and I thought it turned out really good. Taking a look at some of the features that we changed and I added, right? We wanted access to that electronics, so I boosted this. I moved this canopy up pretty far here, so we have easy access to those electronics, making it a lot easier to make any changes, unplug, or reprogram anything that needs to get reprogrammed. Another thing that we wanted to add was that GoPro. So that's what you're looking here, that cutout here. That's where the GoPro would have sat, right? And because of that, the GoPro is kind of heavy, right? I wanted to beef up the top there to make sure it's sturdy enough to to hold that GoPro. And then I was pretty proud of this first design, right? But I didn't add all the features, knowing I'm probably gonna have to change a bunch. But I posted it onto the platform. I was like, hey, Breland, what do you think of this design? And let's take a look at what those comments were. Right, so you say, hey Dan, that looks really great. However, you need to shell out the canopy to make it as light as possible, and also lower that canopy as close to the frame as possible. And I was like, all right, I think I understand what you're saying, but let's jump on a call just to make sure that is what you're saying. And for some of you, you probably are anticipating that's exactly what he's asking to do, is to move this canopy as close to this electronics as possible, basically getting rid of all that area I left there to work on the electronics, and all of that extra thickness up there to support the GoPro, get rid of that, because the lighter it is, the better. It also is pretty thick right now. Right now it's 5 millimeters. We want that as thin as possible, so we're going to go with 1 millimeter thick. I was like, all right, great. So completely new design again. No, I'm just, I actually modeled this pretty with that intent of making changes. So it was pretty easy to add those and change that after the fact. So let's take a look at what that second revision looked like. And this is what we came up with. Right, this actually ended up being our final revision for the canopy. Right, you can see here this GoPro is a lot closer to this electronics, and that was the whole reasoning why we wanted to move this canopy as close to electronics as possible, or close to the frame, because of the center of gravity. Right, this GoPro is going to be adding a lot of weight to our quadcopter. So when flying, the flight controller and all of the electronics are assuming the center of gravity is where the electronics are, right? That's where the most weight's going to be. However, the GoPro being a little bit higher, it's going to throw that off, going to make it a lot harder, if not impossible, to control while it's in the air. So that was the reasoning behind that. But because I brought it down, right, I needed to add that open area, right, so we have that access to the electronics, also so it doesn't overheat, right? It is a lot closer now, so you don't want it to get too hot in there and damage any of the electronics that way. So this was what we came up with. Breland said that looks great, and then I added the other features that I didn't add, which were the connection points for the camera and the connection points for to the actual frame. And then my role here in the quadcopter project was pretty much done here. So I'm gonna pass it off to Breland, and he's gonna talk a little bit about some of the electrical stuff he did, and then just finish off the presentation with the actual 3D print, the actual final builds, and his experience there. So I'm gonna give it off to Breland now.
Okay, thank you, Dan. So knowing that this year we're not only going to redesign the quadcopter frame, but we are also going to build it this year. So that was very exciting. So with all of the electronics that we went with, I spec'd out the electronics and decided what was going to be the best fit for this quad and what we're trying to accomplish here. So we did go with some premium high-end electronics. So I went to SolidWorks Electrical, create a line diagram to represent all of our layout of these components to share with the rest of the team, so they can get an understanding also of how this is going to be built. I also did the building and the wiring of all of the quadcopter. So I used SolidWorks Electrical to create all of our components here. These are our exact components that we use on the quadcopter. I made those into smart components. I went to the properties and added all the metadata assigned with all of these components. And that was able to give me just a better layout, get a better feel for the team and explanation, and also move forward and get a good bill of material for purchasing. So the next slide here, I exported out a report of all of the components that we used. As you can see at the top of the screen, that came from SolidWorks Electrical and 2D. It referenced all of the part numbers that I used, the marks, and then the descriptions as well. I used some smart links associated with the properties as well. And then we could use this information later on if we ever wanted to, which we probably will in the future. And maybe we'll add some 3D models to this, and then we'll take this into 3D and use some auto routing and route all of these components from our electrical 2D project. Everything's be driven from our 2D project. We won't do that during this MIP, but maybe we'll do it in another video later on in the year. So from the electrical report up top, We exported that out in Excel to our parts list for purchasing. And then I put together the prices for all this, and we have a subtotal of everything. And all smart links for the references for all of the components later on during the building process. It's going to definitely help you out later on. All right, now we're going to the orientation here. So now that we purchased our parts, we're now waiting for those parts to arrive. We can dive into some of the 3D printing on this. So this was also another fun part. With the same sort of shape of the frame last year, we are dealing with just only 3 parts, quantity 4 for the arms. We want to figure out what's the best orientation to print these parts. And we're going to use carbon fiber infill. So we want to sandwich the carbon fiber infill. And the whole main goal of this was for strength and rigidity. So to do that, we would need to orient the parts flat, should be horizontal to their z-axis on the print bed. And we'll show you that in the next scene here. But what you don't want to do is mount prepare the parts in the vertical orientation. And these are all going to be done on FDM printer. And as you can see from the left side of the screen, the very first image is positioned vertically. That's not what you want to do. It's not efficient. It's not going to be a good strength. It's not going to give us any good strength characteristics when we're mounting this down. And also, it's not going to give us very good printing orientation for using hardware in those round centric holes. And it's also going to add a lot of infill, which we don't want, because that's going to equal out to be more material and also more post-processing. So as the end result, this is the way that we laid our prints out on the print bed. We used the MARKFORGED X7 for its exquisite printing capabilities, and also using the carbon fiber insert. We just have a quick screenshot of how the fiber fill was ran on one of the bottom plates, and then our finished part products and how everything was laid out. So this was a pretty quick print. This took about 4 hours to print all of the parts, as you can see on the print bed, and everything ran very smoothly. Very, very nice parts. All right, we'll move over to the fiber infill. So we use an isotropic fiber infill, and with this fiber infill, it consisted of a very strong fiber infill, very strong parts. So the very first image we're going to look at is one of the arms. For the arms, we use a full carbon fiber insert throughout the whole entire part, except for the top 2 layers and the bottom 2 layers, to make sure that the carbon fiber isn't going to be exposed and everything is nice and seamless. The next image over in the middle is going to be your top plate. As you can see, the way the fiber was ran with the representing in the blue lines, and how we use the isotropic also infill as well. And that infill will then turn those fiber runs to make sure that we have as much strength as possible, rigidity as well. That fiber was only ran on the 3rd and 4th layer, and then also the 5th and 6th layer on the bottom. So that wasn't just a smaller plate, so we just need a little bit of stiffness for that. Unlike our last image, which is the main plate, it's the bottom plate, we use carbon fiber running through the entire print of that part. That's going to be the main meat and potatoes, the main beef of the frame. That's where our electronics are going to be mounted. And also our arms are going to be sandwiched on that plate. So we used carbon fiber throughout that entire plate as well, except for the top 2 layers and the bottom 2 layers. All right, so this will take us into design for additive manufacturing. Why this is so important? This is a subset of DFM. So the 3 typical, one of the 3 most popular 3D printing process are FFF, which is formerly used by MARKFORGED and also can be known as FDM. That was what we used for the X7. The SLA is one of the next print types, and that is a liquid resin. So that has a vat at the bottom of a build plate. It's filled up with resin, and then it has a light or a laser that would solidify those bottom layers, and they're sandwiched together and they're pressed down from a build plate that's lowered down into the resin. SLA prints are known for their unique detail. And those parts look a lot like injected molded parts because you can't see really any layer lines. They come out very nice and for detail. And DMLS process as well. We didn't use that at all, but we did use the FFF or FDM, and we actually did use an SLA print, which we'll discuss a little bit as we go further along. All right, so the canopy here, this is going to include our FDM print and also the SLA print that I was telling you about. So of course, everything, not everything runs smoothly from time to time. So we did have a fiber jam and we're kind of pressed for time. So I used my SLA printer as a backup to print one of the canopies. And what you can see in the pictures, I should describe as the whitish or opaque color is the SLA print. And as you can see, the FDM print, which is very comparable to the SLA print. All right, the reason we want to compare this to is that is very, very impressive that the FDM print from MARKFORGED on the X7 is that comparable to an SLA print, which is the SLA print, as I said before, is kind of replicates an injected molded print because the detail is just so nice. So the FDM print is the black print on the right-hand side, and that came out just as nice. And we were going to use the SLA print maybe for some different effects. Maybe we threw some lights underneath the canopy on the actual quad. It'll give a nice glow effect and give it kind of a nice illusion when we're flying, so we can get a good representation, in the air if we're flying line of sight of what's front, what's back. But the FDM print came out so nice, and the optics, it just looks so nice, and the finish is so nice. We're just going to go with the FDM print, which is all black. It's black print. Okay, and one of my favorite parts also is the build process. So I was in charge of building the frame. Now that the parts have arrived, our purchased parts have arrived, our first image that we'll show you here in the far left is going to be the frame as it came off the bed. There's no post-processing that needs to be made because the X7 prints so nice, and it is very, very, just very detailed. There's no post-processing that needs to be involved. The only thing I did in that picture was put in the lock nut inserts. And as if I didn't say before, we had one revision which we made to the bottom plate, and that was to add in the little insert holes or relief holes for those little inserts. That way they fit flush instead of having a larger lock nut that would stick out and act as a snag point when we're flying the quad, if it ever got snagged on anything. So it's lower profile. That's the same, works the same way. Next image over, I have the bottom plate that's mounted. One of the arms mounted. I have one of the motors just laid out. I shrink wrap the wires to the motor just to make sure that we tuck the wires around, make sure that we don't have any blade lash of cutting those wires. That will require a brand new motor if that's the case. So those down in, shrink wrap those around the inside of the frame, going to the ESC. And I mounted the ESC inside the quadcopter frame in that picture. And then what you see is the top plate on top, and there's actually two plates there, both of the same profile. The top plate just has a hole, so the electronics can stick out, and everything has a nice low profile all the way down towards the bottom. The next image over, I mounted all four arms, have all those wires. I'm trying to figure out the wiring of the motors, of how I'm going to keep everything nice and tight and close inside without having, because you don't want any wires that are sticking out or snag points and damage electronics. Down the bottom, we're going to fast way forward all the way to the end, and this is the complete build process with our flight controller, our ESC, our receiver, and also our video receiver as well. So, and with our lights at the end. So that's the finished build of just the quad. You won't see the camera. The camera is actually a unique design. That's the camera that's mounted inside the canopy. So that is just a small little plug that plugs in once we mount the canopy on. Here is our finished build. Our finished build is going to consist of the FDM print from the MARKFORGED. This is represented in all black. I think it turned out very nice. We have going with some nice alien green props, so everything looks nice and fresh and new, ready to rip. And yeah, I think it turned out really good. It was great working with Dan and the rest of the team. This was a very fun project. And I think it turned out fantastic. I think it looks really good. Now we just need to get some video footage, and we'll show you guys how fast this thing really performs. By the way, this is capable of 6S power, which is 22.2 volts of power. So this thing can really, really fly fast. It should be capable well over 100 miles an hour. And last but not least, we just have one more rendering here. Compared to our last year's rendering, we used Visualize Professional for this, and as you see on the left is the turtle from last year's model compared to this year's alien. And as you can see, the alien is taking the lead, banking around the inside of the corner, and it's going in for the win. That's everything that we have here. It was a pleasure working on this project with Dan and Abby, and we'll take any questions if anyone has them at this time.
Great, yeah, and thank you. And then any questions would be great. We'll be able to answer those in the chat. Thanks.
Thank you.